Nurhanan and welcome to our project presentation video. So in this video, we will explain how the component were chosen based on the research, and then we will show the component connection and explain why they use. And then finally we will go through the program code and also explain how it works. We will also explain the web uses in our system, and I will pass to my friend to explain more about our project video.
Okay, thank you. Next, on my part, I'm gonna present to you the component that will be used based on our research that have we done. So, for the first thing, DHT22, the reason why we choose DHT22 other than DHT11, for both of them, function is to detect or measure the temperature. But on DHT22, we will get more precise result in and high accuracies, while the DHT11s still produce a good result but not as accurate as DHT22. FSR, potentiometer, and SP32. The SP32 focus on to put the code and to control our systems. The DHT22 to detect our temperature in the shoe. The FSR is to detect the pressure on our shoes. And then we also have 3 LED just for prototypes to measure either the conditions is good, health, or in between. So the LED that we use is green, yellow, and red.
Assalamualaikum warahmatullahi wabarakatuh, and hello, my name is Manin Hekan, and in this video I will explain why specific pin and resistor component are used in my project. For the first one is FSR pin and potentiometer. First, the force sensitive resistor or FSR is connected to GPIO 35. This pin is selected because it is an LEC1 pin which provides stable analog reading even when Wi-Fi is active. GPIO 35 is also an input-only pin, making it ideal for sensors that only send analog data. And instead of using fixed resistor, I choose to use a potentiometer to form the voltage divider with the FSR. The potentiometer allows me to adjust the sensitivity of the FSR by changing the voltage range. This is useful for calibration, especially when the applied force varies between user or testing condition. And by tuning the potentiometer, I can ensure the SP32 receives a clean and usable voltage range without saturation or noise. And the main reason for using a potentiometer is flexibility. A fixed resistor gives a fixed sensitivity, but potentiometer allows real-time adjustment, making the system easier to calibrate and more accurate during testing and demonstration. And for second one, I use DHT32 pin and pull up. The DHT32 pin, the 32 data pin, is connected to GPIO 14. This pin is chosen because it is a general purpose digital pin that works reliably with timing sensitive sensor like the DHT32. The DHT32 required a pull up resistor on the data line to maintain stable logic level. But in this project, the DASP32 internal pull-up is sufficient to ensure the reliable communication without extra component. And for the third one is LED pin and current limiting resistor. The green, yellow, and red LED are connected to GPIO 16, 17, and 18 respectively. And these pins are selected because they are simple digital output pin, which is suitable for controlling LED. And each LED use a current limiting resistor, and I choose to use a 220 ohm resistor to protect both the LED and the SP32 from excessive current. And finally, in conclusion, GPIO 35 is choose because for accurate analog input, and the potentiometer improve FSR calibration. GPIO 14 ensure reliable digital communication, and the LED resistor provide essential current protection. And that's why each pin and resistor is carefully selected in the system for this project. And that's all from me. I will pass to the next person for explain about the next part.
Assalamualaikum warahmatullahi wabarakatuh, and hi, welcome back with me, Nasim Rifki bin Muhammad Fuad. And for today, my part in this week video is I'm gonna walk through you guys about our coding for our system, and I'm just gonna read our coding to you guys and have my friend Firdaus after this to explain one by one the coding for each coding line. Okay, so first I'm going to start with our library. We need to define Blink template. We need to define Blink template name. As in this system, we put as a feed because it suitable for our system name for our project. And the next one is define our token, which is our code. And we include library for our DHT, which is our sensor, and include Wi-Fi, and include Blink simple ESP32, which is our microcontroller that we use is ESP32. And then we put a character, authorize, SSID, and pass laptop, which is SSID is in our laptop, and pass is our password, of course. And back to our library, we define FSR pin 35, which is we need to pin switch put the pin at 35 pin, and DHT at pin 14, and DHT type is DHT22 for our sensor DHT. And this is our LED pin: green LED at pin 16, yellow LED at 17, red LED at 18. Okay, so next, for our DHT pin and DHT type, we start our coding with a void setup. Serial begin 115200 and DHT will begin. And then we continue to analog read resolution, which is 12, and analog set attenuation is ADC 11 underscore 11 dB. And this is for our output green LED output, which is pin mode green LED, yellow LED, and red LED. And this is our digital write: green LED low, yellow LED low, and red LED low. Then we open up with our next void loop. We loop our system. In this void, in this coding, is integer FSR value equals to analog read. We get the analog read from our sensor FSR value. Okay, FSR pin. Yeah. And then we put float H equals to DHT read humidity, and T represent temperature. So H represent humidity and T represent temperature. Okay, so if is none H and IS and ANT, so serial print DHT read fail. Okay, and it will return to our coding on top. So this is the function of our void loop. And then we put bool IS comfortable. So this is for our comfortable range, which is our temperature is more than 27, and our end temperature is below 32, and humidity more than 60 and below 18. So FSR value overall need to be below 18 and below 1500, sorry. And then this is for our discomfort: temperature more than 32 and under below 35 or equals, humidity more than 80 and equals or below 19, and FSR value will go more or equals to 1500 or below and equals to 2500, and it will calculate as uncomfortable. Alright, so this is the same thing. 27 uncomfortable, or this is slight uncomfortable, this is uncomfortable, sorry, my mistake. For this part is slight uncomfortable, and this part is uncomfortable. For uncomfortable, which is temperature below 27 and more than 35. For humidity below than 60 and more than 90. For FSR value is more than 2500. Right? So if uncomfortable, green LED low, yellow LED low, red LED high. So which is green LED will not light up, yellow will not light up, and red will light up very bright. Yeah, so it's for uncomfortable. For this comfortable, slight discomfort, yellow LED will high, and both green and red will be low. And for comfortable, which is you guys may know, green of course will high and yellow and red will low. And that's for our LED output, and this is our serial output. Serial print FSR, serial print FSR value, and blink virtual write V2 FSR value. And it will print, serial will print temperature, which is represent T, and serial print Celsius, and blank virtual write V0T. And serial print hum for humidity, which is H, and it will print a percentage symbol, and blink virtual write will V1H. So for temperature, V0, for humidity, V1. Alright, T temperature, H for humidity, basically we know. And lastly, we put delay for 1000. Yes, and that's all for me. This is my part, and I will continue with you guys next week. Okay, now we go to my friends Firdaus for explanation for each code. Thank you so much.
Assalamualaikum guys. Okay, today I'm going to show you, I'm going to explain to you about the code that we're going to use for this mini project. As you can, as you all knows that we are going to use Blink. So this three line of code up here is very important for our Blink template that we're going to use. As you can see, first we have the template ID, and then we have the template name and also the authentication code. Authentication token, which is very important to connect our ESP with a Blink, as we want to see the data that we're going to collect. So here are the token that I'm going to use. Also, we have a few line of library that we're going to use, which is DHT, Wi-Fi, and also we're going to use Wi-Fi in this project also to ensure ourselves that we can connect our ESP to Wi-Fi and also bring simple ESP32. Here are the password and ID for the Wi-Fi that we're going to use. And down here on line 30 to 15, which is we are declaring the pin that for our sensors, which is FSR on GPIO 35 and DHT on GPIO 14. Also, we have few LEDs that we're going to use, and we declare their pin, which is on 16, 17, and 18. And here are the call out for the library usage that we're going to use to activate the DHT library itself. And then we're going to look at our board setup. First, we have serial begin here to ensure the baud are the same with our serial monitor that we're going to use, as you can see here. We're also going to see our data on serial monitor as well as blink. And then the DHT begins code to start our DHT. And here are the analog read resolutions. Typically, we are using 12 because the FSR sensors are using analog. So we're going to use uh, analog read resolutions as well as the analog set. Uh, Next, we declare the pin mode for the LEDs, which is all for the outputs. And then we start on the setup to ensure all LED stay off when the setup process is going through. For the void loop, first we are going to declare or we're going to take our FSR value from the analog read from the FSR pin that we are already declared earlier on GPIO 35. And then also we're going to read the DHT data, both the humidity and temperature, and store it in integer and also float for the DHT. Here are the failsafe that we're going to use, which is if DHT are not giving us the data, the serial will print. We can see on the serial display it will write DHT22 read fail. Next, these are actually the threshold that we're going to use. For comfortable, the temperature will be less than 27 and more than 27, I'm sorry, and less than 32 degrees Celsius, and humidity will be more than 60 and less than 80, and also FSR value on Pascal. We are going to use Pascal from this early stage, which is 150, sorry, 1500. And also, if slightly discomfort, it will be more than 32 and less than 35. Humidity will be 80 and less than 90. And also, FSR value will be between 1500 and 2500. Also, the uncomfortable phase, which is um less than 27 and more than 35. Also, I forget to mention that we can always change the threshold to meet our satisfaction, which is anything we want to put it. Let's say I want to put it on 40 to make it uncomfortable. I'm sorry, to make it uncomfortable. All right. Then what's going to happen if the threshold are met? So when the reading are uncomfortable, the red LED will turn on and the others will turn off. And also, if slightly discomfort, only the yellow LED will turn on. And is comfort, which is comfortable for usage, the green LED will turn on. And here's the line of code that we show will print both on our serial display and also on Blink, which is we already put Blink virtual right here, and also on V2. So virtual pin 2 will show FSR value. Virtual pin 0 will show temperatures, and also virtual pin 1 will show humidity. So this is a very simple code. If you have any questions on this code particularly, you can always put your question in the comment. I will try my best to answer it for you. Thank you.
Blink is an Internet of Things IoT platform used to remotely monitor and visualize sensor data through a mobile or web-based dashboard. In this project, Blink functions as a cloud-based interface that receives real-time data from the ESP32 and display it in an organized and user-friendly format. Blink configuration in the code. The Blink platform is initialized using three essential credentials: Blink template ID, Blink template name, Blink author token. Template ID and template name link the ESP32 device to a specific Blink dashboard design. Authentication token uniquely identify the ESP32 device and allow secure communication with the Blink cloud server. The Blink library from ESP32 include using Blink simple ESP32.h. The library enable the ESP32 to send sensor data to the Blink cloud over Wi-Fi. Data transmission to Blink. Sensor data is sent to Blink using virtual pins, which acts as software-based communication channels between the ESP32 and the dashboard widgets. V0 display temperature data on the Blink dashboard. V1 display humidity data. V2 display force sensitive resistor FSR pressure value. The virtual pin are connected to gauge widget in the Blink web dashboard, allowing real-time visualization of environmental and pressure conditions. Real-time monitoring via Blink dashboard. The Blink dashboard, as shown in the image, use Gauss widget to present temperature in Celsius, humidity in percent, and FSR pressure value. The ESP32 update this value every second, enabling continuous monitoring. This makes the Blink suitable for applications that require live feedback, such as comfort monitoring system or wearable relay sensing project. Role of Blink in overall system. In this project, Blink serves as a remote monitoring platform, allowing users to observe sensor reading without direct physical access. Then, a data visualization tools presenting complex sensor data in an intuitive graphical format. Third, the cloud communication bridge between the ESP32 hardware and the end user. By integrating Blink, the system achieves real-time IoT functionality, improving accessibility, usability, and scalability for future enhancements such as alert or data logging. That's all for me. I pass to next person to continue our presenting.
Hi guys, my name is Nabat Ahmad bin Nazri. I'm from IAC 5B in this group. Now in the last section for my explanation is a conclusion. This mini project is successful, show how a smart Insole can be used to monitor comfort in real time by combine a pressure, temperature and humidity sensoring. By integrating the FSR, DHT22 and ESP32, the system is able to continuously observe what is actually happen inside the shoes, something that user normally can feel and measure accurately. And with the comfort classification logic, the system can clearly determine whether the foot condition is comfortable, slightly uncomfortable, or uncomfortable. This condition are easily understood by the using LED indicator, while the data can also monitor it remotely using by Blink IoT platform. In this real-time feedback, help user become more aware of unhealthy conditions such as exercise pressure, heat and moisture before they lead to discomfort or injury. And the last one, overall, this project demonstrates that combining sensor fusion with IoT technology can provide a practical and low cost and less efficient solution for the comfort monitoring. With future improvement such as data login, mobile notification, and better wearable integration, this system has strong potential to be applied in health monitoring, sport performance, and the last one, diabetic foot care. Thank you guys to see our video. Don't forget to subscribe, like, and share. And the last one is comment. Bye.